time for another episode of TechFix. Today, we're taking on one of the most critical systems on the all-new Mack Pioneer, the starting and charging system. We'll look at how the single and dual energy storage systems work, what the battery sensors and the alternator are doing behind the scenes, and why state of health and state of charge are two numbers every technician should pay attention to. We'll also cover when to repair and when to replace, and break down the Battery Power Management Unit, or BPMU. If you've battled parasitic drains, mysterious no starts, or batteries that just don't last, this episode will give you the knowledge to solve those issues right away. Everything we're covering today is backed by CBR 2404, 2454, 2435, and 2466. Let's begin with the Single Energy Storage System, or SESS. In this design, one set of batteries does everything. It powers the starter motor during cranking, runs every ECU and accessory, and recharges through the alternator once the engine's running. This approach is simple and reliable, but because one battery pack is doing it all, it carries a heavier workload and is more vulnerable to parasitic drains. The Dual Energy Storage System, or DESS, separates the workload. A dedicated starter battery, the ultracapacitor, is reserved strictly for cranking. The living batteries power everything else to include ECUs, HVAC, lights, and accessories. That separation guarantees strong starts even when accessories have been drawing power. In a way, it's a safeguard against no starts, ensuring the truck always has the energy to turn over. At the center of both systems are the battery sensors. They measure voltage, current, and temperature, then calculate state of charge and state of health. That data goes to the CCIOM, the Center Chassis Input and Output Module, which commands the alternator through the LIN signal, while the VMCU continuously adjusts voltage to keep the system balanced. The alternator itself can produce up to 28.3 volts, but it never exceeds the system's capacity. Voltage drops as temperature rises, and once the batteries are full, output is reduced to prevent overcharging. The alternator doesn't just recharge batteries, it also shields the system from damaging voltage spikes. Because the battery sensors are the foundation of the charging system, correct installation and service are essential. A single wrong connection or skip calibration can throw off the entire system. When reconnecting, following the order of operations is very important. Start with the ultracapacitor line first, then ground, then battery sensors. It's important you do this before turning the maintenance disconnect switch back on. In a 4-battery setup, sensor 1 belongs inboard and sensor 2 outboard. In a 6-battery setup, sensor 1 is inboard, sensor 2 middle, and sensor 3 is outboard. Harness labels may fade or go missing, but just to be sure, use a multimeter on the harness code pin and confirm against the schematic. Finally, when replacing a battery sensor, calibrating will always be required, but programming may not be. This will depend on which battery sensor part number you have. Please refer to CBR 2435 for guidance on battery sensor replacement. Also, a quick tip, a misplaced sensor or skip calibration won't just set a fault code, it can take the entire charging system offline. Always verify before you calibrate. State of health, or SOH, tells you how a battery compares to when it was new. It measures both its ability to hold a charge and its ability to deliver energy under load. A new battery starts off at 100% state of health. By the time it drops to around 85%, capacity is reduced, meaning a full charge isn't really full anymore. At 50% state of health, the battery is considered damaged and must be replaced, even if the state of charge reads 100%. Guess what? In the event this occurs, the truck will alert you. There's also a critical rule. When batteries are connected in series, their state of health and cold cranking amps must be equal. Never mix old batteries with new batteries. That mismatch leads to uneven charging, shortened lifespan, and even pack failure. State of health checks should always be done before delivery, after storage, and any time there's a persistent drain or charging issue. State of charge, or SOC, shows how much energy the battery has available at the moment. At 100%, the chemistry inside is balanced and healthy, but if state of charge remains below 80% for too long, sulfation begins to form, which permanently reduces the battery's ability to hold a charge. If it's fully discharged, both plates convert to lead sulfate, the electrolyte turns to water, and the damage can't be reversed. Before delivery, state of charge should be at least 85%, which equals 25.2 volts or more on a 24-volt system. Testing should never be done right after engine activity. Wait at least 5 to 10 minutes in park mode. For accuracy, always use a tester with state of charge display, not just a voltmeter. For storage, state of charge should never drop below 80%. If it does fall under 12.54 volts, recharge within 24 hours. For long-term storage, recharge every 3 weeks. A fully charged battery can withstand freezing temps as low as negative 88.6 degrees Fahrenheit, but a discharged one can freeze at just 19.4 degrees Fahrenheit. Remember, heat speeds up self-discharge, doubling the rate with every 10-degree increase. Keys left in the ignition or inside the cab can keep the truck in living mode, preventing full shutdown. Depending on configuration, that can leave modules awake for 2 to 12 hours. With keys removed or stored on the wireless pad, the truck transitions to park within 30 minutes. Using the battery saver switch forces park mode immediately, and if parked for more than a month, the MDS should be turned off to avoid drain. Remember, a hot day in Texas can drain a parked truck just as fast as a freezing night in Minnesota. Always take the environment into account before assuming the battery or charging system is at fault. Oh, and one more thing. Within TechTool, there's a test called battery status data. It can be used to provide you with all this stuff. That's a lot of stuff. Additionally, this test can be used to get state of health in order to justify replacing batteries. In the Pioneer battery box, the batteries are divided into 2 banks. The low side batteries make up the 12-volt section, while the high side batteries make up the 24-volt section. You'll see these terms used in wiring diagrams and service procedures, so knowing which side you're working with is critical. Proper identification matters when you're charging or diagnosing, because each side has a specific role within the system. Also, remember the 12-volt side is red and the 24-volt side is yellow. So when do you repair? When do you replace? If the state of health is at 50% or lower, if the state of charge continues to drop and won't recover, or if there's visible sulfation, freezing damage, or physical failure, it's time to replace. ECU diagnostics may also trigger replacement, and batteries left sitting for over a year often won't recover. Now, if state of charge is low, while state of health remains good, the battery may only need repair or recharging. Parasitic drains are a common culprit caused by keys left in the cab, HVAC or inverters left on, or ECU staying awake because the MDS or battery saver wasn't engaged. The inverter is another major source of silent drain. If left on when the shore power is connected or disconnected, it can remain active indefinitely. Always confirm that the inverter's green LED is off to prevent unnecessary power loss. Before replacing, always disconnect using the proper MDS procedure. Charge with a smart charger like a NOCO Genius Pro 50 or Autometer Bus Pro 620. Shut down major draws like HVAC and lights and confirm proper key storage. Cleaning battery tops to prevent leakage, using boost charging or gentle tipping to fix stratification, and applying controlled overcharge to reverse mild sulfation can also extend life. But never mix old and new batteries, always replace them with a complete set. During software updates or service work, best practice is to start with batteries at least 85% state of charge, HVAC blower turned off, and inverter and fridge switched off. The MDS must be off during electrical repairs and the ultracapacitor ground disconnected for BPMU or starter work. These are the 3 most common issues that keep trucks coming back to the shop, all of which are preventable with a quick check before walking away. Okay, I'm ready. When a truck requires external charging, always use the external charging interface. Never connect directly to the engine start module or ultracapacitor. The ECI marked with the red cap is for 12-volt charging only. That's where you connect your charger. Loose or incorrect connections can cause damage, so always double check your leads before starting. If state of charge is too low and a smart charger won't recognize the battery, switch to power supply mode to raise the voltage. Charging times vary. An ultracapacitor and a DESS can be ready in 1 to 5 minutes, while an SESS battery bank may take 30 to 60 minutes. If the high side batteries drop below 10 volts, start by charging the low side batteries through the ECI. Once those stabilize, move the charger leads directly to the high side battery terminal on the back side of the MDS to bring the entire pack back up. This staged approach ensures the truck accepts the charge correctly. Keep the truck running or charging until state of charge reaches 85% or higher, and replace the ECI cap when finished to keep water and dust out. Remember, safety first. Never bypass procedures around the ultracapacitor. Sparks or incorrect connections here can damage sensitive modules or cause personal injury. And a quick rule of thumb, always hook the charger to the external charging interface first, never straight to the starter battery or ultracapacitor. It saves modules. For 24-volt charging, connect the positive lead to the outboard high side battery terminal on the back of MDS and the negative lead to the ECI negative post. Don't connect the positive lead to the ECI. That's restricted for 12-volt charging only. Using the correct points prevents system damage and ensures the batteries charge evenly. So if the truck is completely dead, shore power may not charge the batteries. Traditional charging methods may be needed first. If charging fails through the ECI, check the 500 amp Z-case fuse. On 4 and 6 battery setups, it's mounted at the battery end of the positive ECI cable. On 2 battery setups, it's mounted at the ECI end of the cable. Oh, on trucks with an inverter, you can also plug into shore power connector on the driver's side. The ultracapacitor is ready in as little as 1 to 5 minutes, but keep the truck charging until state of charge reaches 85%. If charging from another truck, follow the 12-volt procedure when using a legacy 12-volt truck, and the 24-volt procedure when using a 24-volt truck. The Battery Power Management Unit, or BPMU, acts as the traffic controller for the truck's electrical system. It balances energy between high side and low side banks, manages distribution, and integrates charging functions. In a DESS setup, it balances power between the vehicle battery and starter battery. It also houses the DC converter that charges the starter battery in both directions and the communications interface for the 24-volt grid charger. Without the BPMU doing its job, distribution and balancing across the system would break down. So let's recap. The SESS and DESS define how energy is managed in the truck. The battery sensor and alternator work together to monitor and adjust voltage, protecting both the batteries and the electrical system. State of health and state of charge are the key indicators of battery life. Replace at 50% state of health and never let state of charge fall below 80%. Following best practices for repair versus replacement prevents wasted time and unnecessary costs. Finally, the BPMU is central to balancing power, but it requires strict service discipline. Remember, 12-volt jump charging must be done through the external charging interface, and 24-volt jump charging must be done via the back of the MDS. Keys must be stored properly to prevent drains, and inverters should be verified off when not in use. These small checks prevent some of the biggest causes of premature battery failure. Understanding these systems saves time, prevents no starts, and keeps trucks on the road. We'll catch you next time on TechFix.
That's a wrap.